Hello class, this is a continuation on the domain and range of the inverse function. In this video, we'll be looking at restricting the domain. As seen previously, not all inverses of functions are themselves a function. We know that if a function is not one-to-one, meaning that it will fail the horizontal line test, then we know that that its f inverse is not going to be a function. So if this is a function, doesn't necessarily mean that its inverse will be a function, but we do know that if it fails the horizontal line test, its inverse will definitely not be a function. To elaborate further, any function with a turning point will not be one-to-one. So the inverse of any function with at least one turning point will not be a function. Let's take a look. Any function with a turning point will immediately fail the horizontal line test. This one has 3 points, 1, 2, 3. We'll cut through at 3 points, which also means that the inverse of this, it'll fail the vertical line test because it will cut 3 different points. And I think you get that idea. If it has a turning point, it will fail the horizontal line test. So to make a rule from this, for any function f of x, its inverse f inverse of x is a function only if f of x is either always increasing or always decreasing. That's just another fancy way of saying that there's no turning point, because take a look. In this one, the function is increasing at these points until here, and then from here it's decreasing. So this is not always increasing because it's increasing and then decreasing, meaning there's a turning point. So by restricting the domain of f of x, it is actually possible to make f inverse of x a function. So take a look. Normally, this function has a domain of negative infinity to positive infinity, and its range is going to be from 0 to positive infinity. And so when we try and find the inverse, we come to this point where we have that plus minus. Hence why, well, now we know that plus minus means it'll fail the vertical line test. But now we can restrict the domain of this so that it's either always increasing or always decreasing. I want you to think about for a moment, what can we restrict this domain to so that this function is always increasing and always decreasing? So we're going to have two separate functions now. Well, as you can see, 3 being the turning point, x equals 3 is the turning point. Everything to the right of this is increasing always, and everything to the left of this is decreasing always. So the function is always increasing in this domain. So from 3 to positive infinity, the function is always increasing. And from 3 to negative infinity to its left, it's always decreasing on this side. So if instead of just saying f of x is equal to this function, if we restrict the domain to one of these two, take a look. If we say that the function is now f of x is equal to x squared minus 6x plus 8 for this domain only. Now, the graph of the original function, which was once a parabola, now only exists to the left of that parabola. Now take a look. That is now a function. Its inverse is now a function. Likewise for this, if we just selected x is greater than 3 for the same function, the function only exists on the right hand side of that turning point. And so what was once a sideways parabola like this now only has one arm. Hence, the inverse of this function is always the inverse of the function is a function itself. So looking at this, just have a quick pause, and I want you to write down the domain and range of the inverse now that you see this one. Okay, so let's pick this first. Well, if you took a look here, its domain now, since this is now a function, we can follow the rule that the domain of the inverse was the range of its function. So the range of this is from -1 to, oh, sorry, my apologies. Oh, sorry, my apologies for this one. It's, sorry, yeah, that's right. Its domain is from -1 to +infinity. Had a little bit of a moment there. Let's take a look. It starts at -1, and we can input any x value up until +infinity. And its range, take a look, its highest value is y is equal to 3. 3, whoops, we're going the wrong way. So its highest value is 3, and its lowest value is going to go all the way down to -infinity. Notice how it's just the switch of the domain and range of the original function. And then from this, rather than plus or minus square root of x plus 1, this function now is only f of inverse of x is equal to 3 minus square root x plus 1. And there's our inverse function now. And for this, I think you get the idea that we can switch these around. So its domain is going to be -1 to +infinity, and its range is going to be from this time 3 upwards to +infinity, because it starts at 3 and it goes as high as +infinity. And the function of this one is the positive version of the inverse. So let's just copy this and get rid of the negative. So I hope that gave you an insight into restricting the domain to make the inverse of a function an actual function itself. Hope to see you in the next video. Best of luck.